Hi students, this is Srinivas and you are watching KAB television. Welcome to E-Classes. ఫిజిక్స్ అంటే వణికిపోయే ఇంటర్ విద్యార్థులకు టిప్స్ అందించేందుకు KAB టెలివిజన్ కృషి చేస్తోంది. అనుభవజ్ఞులైన అధ్యాపకులచే ఫిజిక్స్ క్లాసుల్ని నిర్వహిస్తోంది. విద్యార్థులు చేయాల్సిందల్లా KAB వెబ్ టెలివిజన్లో ఈ క్లాసెస్ను రెగ్యులర్గా ఫాలో అవడమే. ఇక ఈనాటి ఎపిసోడ్ విషయానికి వస్తే డాక్టర్ శ్రీనివాసాచారి సీనియర్ ఇంటర్ ఫిజిక్స్ సబ్జెక్ట్ను బోధించబోతున్నారు. ఫిజిక్స్ బోధనలో అపార అనుభవం ఉన్న డాక్టర్ శ్రీనివాసాచారి గారిచే అత్యంత కీలకమైన మెకానిక్స్ చాప్టర్పై ఇవాళ క్లాస్ కొనసాగుతుంది. గత ఎపిసోడ్లో మెకానిక్స్ టాపిక్కు సంబంధించి సెంటర్ ఆఫ్ మాస్లోని యూనిఫామ్ సాలిడ్ కోన్ మరియు యూనిఫామ్ సాలిడ్ హెమిస్పియర్ గురించి తెలుసుకున్నాం కదా. ఈనాటి ఎపిసోడ్లో హాలో కోన్ మరియు యాక్సిలరేషన్ ఆఫ్ సెంటర్ ఆఫ్ మాస్ గురించి అధ్యయనం చేద్దాం. పరీక్షలో చాలా రెగ్యులర్గా అడిగే ఈ సబ్జెక్టుకు సంబంధించిన లోతుపాతులేంటో డాక్టర్ శ్రీనివాసాచారి క్లాస్లో తెలుసుకుందాం.
Next we go for hollow cone, uniform hollow cone, right circular cone. Now we will be considering the center of mass of a hollow cone. Hollow cone, let it be a uniform hollow cone, symmetric to y-axis or axis along the y-axis, and base, center of the base is at the origin and base is on xz plane. It is like this. How to determine the center of mass of a hollow cone? Procedure is, imagine that be divided into small elements. Imagine this be divided into small elements. Okay. So the elements are in the form of circular rings. Those circular rings of varying radius starting from here to at the base. So varying circular rings we can consider. Consider one ring which is of width dl located at a distance L from the vertex. L is the slant distance. Along the slant height of the cone, along the slope of the cone, consider a distance L with a thickness width of dl. So let it be dl. Let this angle be theta and let the corresponding vertical distance or y distance be dy. So when I consider dy as the y distance, dl is along the incline, theta is the angle here, dl and dy they are related to each other. Dy is equal to dl cos theta or dl is equal to dy by cos theta. This is only slightly different procedure we follow. So we are imagining the cone be divided into circular rings of varying radii starting from 0 to r capital R. Consider one circular ring which is situated at a distance L along the slope of the cone with a width dl measured along the slope, and vertical distance or y distance of that width is dy, component is dy is dl cos theta. Therefore dl is dy cos theta, dy by cos theta. Now what is the, let the radius of the cone be r. So what is the mass of the cone? First mass of the cone is m, density. This mass is distributed over the curved surface. Therefore areal density of the cone is mass of the cone divided by pi r l. L is the slant height of the cone which is related to capital R as L is equal to under root h square plus r square, because it's a right angle triangle. R is this, h is this, L is this angle. So therefore we can write as m by pi r into under root h square plus r square. either this way or this way you can write, either in terms of L or in terms of H we can write. Sigma is m by pi r L, that is the cone mass per unit area areal density. Next one is mass of the ring to which the cone is, into which the cone is divided. So mass of the ring is dm is area of the surface area of the ring into areal density. Sigma into surface area of the cone. Cone radius is element disk ring. Ring radius is r, therefore circumference is 2 pi r and width of the cone is dl. Therefore width of the element or ring element is dl. 2 pi r dl is the area of the ring element. Sigma into area of the ring element gives you mass of this element. But sigma into 2 pi r. R once again here also we have similar triangle property. So let this be y distance is, this perpendicular distance is y. The slant height is L, or along the slope it is distance is L. Along the y axis the distance of the ring from the vertex let it be y. So therefore R we can write R by y is equal to capital R by H. Therefore R I can write as small r is capital R into y by H. So using similar triangle property, R divided by y is equal to capital R divided by H. From there I will be able to calculate small r. So I'll write R in terms of y, R by H into y, and dl also I wrote in terms of y coordinate, dy by cos theta. Then what is cos theta in this triangle? Cos theta is H by L. So therefore cos theta is H by L or H by under root H square plus R square. This is cos theta value. And next one is em dm we have. Next determination of YCM. YCM is 1 by m integral y. Y here is coordinate, center of mass is now, y coordinate of center of mass is not y. This distance is h minus y. Therefore instead of y we should write h minus y. That is the location of center of mass on y axis measured from origin. Origin we are choosing here, but y I am measuring from the top in this case. That's why it is h minus y into dm. Okay. Substituting that here 1 by m integral h minus y into dm is sigma 2 pi r by h. I write here sigma 2 pi r h r by h. Sigma 2 pi r by h, I wrote here sigma 2 pi r by h into 1 by m, and h minus y y into dy. Cos theta also I can bring out of the integral because that is also constant. I brought cos theta outside, 2 pi r sigma by h here, m already outside is this integral. Now what are the limits of y? Y0 is corresponding to this ring, y is equal to h corresponds to this ring, y varying between the limits 0 to h. Those are the limits of integration. Therefore YCM is equal to sigma 2 pi r by mh, we write integral h minus y into y dy. Integral, there are two integrals here after expanding this bracket, hy dy minus y square dy integral 0 to h. These are the two integrals. Next comes out to be integration value 2 pi r sigma by mh integral y dy is y square by 2, anyhow h constant, y square by 2 limits are 0 to h is h square by 2, h square by 2 into h cube by 2. Numerator, this is y square dy is y cube by 3, substituting the limits h cube by 3 minus h cube by 3. This is nothing but 2 pi r sigma by mh into 3 minus 2 h cube by 6. So this value. One of the h square, h gets cancelled, we have, and also 3, therefore pi r cos theta we have missed. Cos theta here, this cos theta here, pi r sigma m cos theta into 3 r into h square.